Hello everyone, I'm Dmitry, and you can find me on Mastodon or other social media like YouTube and stuff. And I think like the main reason I did this talk is because I think there is not that much emphasis on refactoring anymore. It's kind of out of fashion, so I thought I'll do a talk to showcase that actually it's still around there and it's pretty cool. And this is a refactoring based on this code kata, which is a coding exercise called Gilded Rose. The most popular version on the internet is under account of Emily Back, and there are lots of different languages. I'll use Kotlin because I use Kotlin on a daily basis. And I'll use IntelliJ and Kotlin, obviously. This will be a happy path. I've done it before, as you might guess, and so it won't be that easy if you try it, just warning. And I might go too fast. Please shout and ask any question at any time. And you don't need really to remember exact details. Everything is already on the internet. Just if you follow this link, you'll get everything that I'm showing, basically. And I'll switch to IntelliJ. So this is pretty much roughly what you get once you check out the project from GitHub. And as a warning, this is going through Meet, so there might be a lag. So if I do something and it doesn't make sense, that's maybe why. So you don't need to know exactly what's going on. We'll see all the details. So there are, as you can see, there are only 4 files here, right? Like 2 tests and 2 classes. So maybe let's look at the test and let's run this test. And if we run it, you can see in the bottom, this flashes that it failed. So you can see that this thing is failing. It's basically expected fix me, but was full. And if we read this code, we can see that we have a list of items, whatever they are. Then we have Gilded Rose. Maybe we should rename it to Gilded Rose. We call update quality on this class, and then we assert that the first item name is fix me, but it was full. So it's like, okay, I guess maybe that's deliberate. And well, let's just fix this test, right? Maybe do a bit of formatting as well. I would something like that. I'm not sure why it's internal. Maybe let's clean this up. And I would just commit it and say fixed test. And that's a test, and there are different ways to do this kata. We can start and write more tests by understanding the requirements, but I'll go with a different approach where I already wrote a regression here. Let's run it and see if it works. And we'll assume that it's good enough. And let's look at regression as well, what it does. So it logs something, this output, whatever that might be. Maybe let's move it here as well to the bottom. And it defines also lots of items. So we can see items, they have name, selling, and quality, 3 fields. And there is a to-do here. So actually, if you read the description of the kata, that's the main goal. It's like a role play that you came to a company and they ask you to implement this feature to add this item. And then similarly, we pass items to Gilded Rose. And then we loop from 0 to 100. And each index in the loop is a day. So we'll log the day, and we'll log the header of items for this day. And then for each item, we go in a loop and basically prints a line of the code. So could convert this maybe lambda to reference. So in case you don't know what I'm doing, I might even use the keyboard. Let me know if it's useful or not. I can turn it off. I can show the keyboard. So if I do alt enter, it shows lots of intentions. And some of them transform in code, but some of them, they really are refactorings, for example, this one. So I think this is a bit more functional way, so that's kind of nice. And once I modify it, I run regression just to see if it works. And then after printing all items, we log an empty line. Maybe that's a better way to represent it. So just definitely an empty line. And each log function, as you can see, it appends the object to output, and then we compare expected output to output. And that's the whole regression, really. So maybe if I collapse this, I can group things like that. So the top paragraph will be set up in test. Then this will be, it's given when then, right? The second part is acting, and third one is assertion. And that's the regression. So I'll commit this as refactoring. And with regressions, it's kind of a bit interesting because, well, how do we know that it works? One way would be to run it with coverage, and we can see now these classes, Gilded Rose and item, they're saying 100%, but is it really true? I think it's kind of questionable. We'll see it in a second. So now looking at the actual code, so there is item class, and it has 3 fields. I think maybe in this case, it's easier to view it like this on separate lines. And it's also another interesting thing, in case you didn't know, there is that's also an intention to put parameters on separate lines, and you can also assign a shortcut to it just from the menu. That's what I have, Alt-Shift-9. That's what I do, or Alt-Shift-8 to collapse them back. I think this looks a bit nicer. It's not clear why this item is open, so if it's open but there are no subtypes and the test's pass, we'll assume that it doesn't have to be. And the other interesting thing, like these, the unnecessary, these dots, so if I remove it, I get notification from IntelliJ that shows, oh, your concatenation can be converted to template. And this is the top result when I do Alt-Enter. So to do that a bit easier, I wrote a plugin called Quick Fix. I bound it to F1 key. It's like help. And so if I press F1, it just uses the topmost inspection. And I know what you develop over time intuition what it might be. So if I just press F1 here, it does this. And that's how I apply intention sometimes. So yeah, that's it. And I'll do lots of tiny commits. And for this purpose, I'll use another plugin that will be commit without dialog. And it's bound to Command S, which is basically commits which become like saving a file. So, they're so granular, it's like pressing the save button in the old days when like hard drive was really slow. So that's the item class. And finally, the Gilded Rose is the class with the most messy code. We can see that like code coverage covers all lines. So, everything is green on the red, but it can only prove that there is no coverage, but it doesn't guarantee like this green line that we covered all invariants. So depending on how much you want to be confident about it, you might do mutation testing, automated mutation testing. That's what I'm doing here is like what if I change it to equals? Will test coverage notice this? It's like, it does. So like undo this then. So yeah, but for now, let's just assume code coverage is good. And well, let's do a quick tidy up as well. So if I press F2, it's like jump into the next error. We can see that IntelliJ suggests it can be simplified. So I'll do like F1, F2, F1, just replacing, without even thinking what it says. I think all of these, they are replacing operator assignment, just simplifying things. And now it's all kind of green test pass, so I'll just do Command S. If you still remember, the actual purpose of this is to add new type of item, conjured mana cake, whatever that means. And like, we can give it a go, like without even like really understanding what we're doing, and say, okay, that's a name, right? So we need to compare, like there are names here. So if it's not equals that, not equals that. Like maybe it goes into here like this, right? Maybe. And yeah, so it will be conjured mana cake. Oops. Let's say it will be this. And if we look at the requirements, we might see, just quickly showing, that like conjured items degrade twice as fast as normal, whatever that means. And it's like, hey, this was -1, maybe that's -2, right? And then if we look at the code below, so it's like this is different name. This is maybe the same thing goes here. And what we expect, because we changed it to -2, we should like regression should fail. And it does fail, but not in the way expected. And like once you hear like, okay, you can go down deep rabbit hole and just like think like why this is failing. It's not obviously why it even fails, not obviously correct. So I'll just go and roll back everything basically and start with refactoring just to show that actually like later on it will be much easier to understand what we're doing. But I think the interesting approach with refactorings is that maybe the most intuitive approach would be like, okay, we'll have to read it top to bottom, create a mental model of what it is, and then we imagine a better state of this, and then we'll somehow imagine steps in between. And this sounds very intense and complicated. But in practice, you can go like simple steps, like, oh, this doesn't look right, let's tidy this up. And through this tidying, we can discover things. So and this is just heuristics, you don't know which approach is going to work. So one thing I try sometimes, collapse everything, which is like Command-Shift-, and then expand it one level at a time. So actually it's just one function and there is one loop. And there are like 3 sections in there. So it's actually that gives us an idea. So maybe all of that, do it again. Maybe all of that could be extracted into functions called update quality, let's say. And then, yeah, that's one heuristic, and it's refactoring, so it will pass the tests. Then we can see item I is used on many lines, so maybe we can extract it as a parameter. And IntelliJ is quite clever. It's like if I undo it, redo, it removed I int with item because I wasn't using it anymore. And that's like, oh, that's interesting. So actually this function could be moved out of the class because items are not actually used anywhere. So that's like a standalone function now, which is cool. And also item is used, as you can see, on every line. So again, we're just going with duplication. Like, what can we do with duplication? Like in Java, it would be maybe a moment we could move this function into item class, but in Kotlin, we have option to do extension function like this. And that's like, okay, it simplifies things a bit more, which is cool. And here, maybe we can see we iterate. In the first place, I use for each because it's less flexible than for. And then I was like, oh, we don't actually need indices. That's what we're doing here, right? And we could convert this to reference as well. So that gives us an idea, like, it's a loop which doesn't have any surprises in there. So that's like a few heuristics here. Then we still have a yellow thing, so I would go and fix like quality minus quality. I guess that's equivalent to equals 0. So that should work. Yeah, and like you still do need to understand what's going on. The other approach I sometimes find useful is to just try and condense code. And sometimes it doesn't work, and it's just like undo later. But here, what we can do, for example, we can alternate and remove braces from if statement like this. There is also join lines action. It's usually doing just line, but here it's clever because it Control-Shift-J, it not only joins, also removes braces, which is nice. And then, for example, if I do here, I can remove braces, but that's not great, right? Or I can merge ifs, right? And if I do Control-Shift-J, join lines, it chooses the right one. Very clever. And yeah, so I'll do Control-Shift-J everywhere, basically now, like this. And maybe here, no. Like this, maybe not ideal, right? It's all fine. So yeah, maybe it's something like that. And the interesting thing now that at least it fits on the screen pretty much, so we can actually maybe look at it and it's easier to comprehend what's going on. So I'll keep it as it is and I'll save it. Another approach that I find useful sometimes is just kind of analyze on some meta level what's going on. So here we know this function only operates on item, which has only 3 fields. So it's like, okay, if I highlight name, I can see it's always kind of green. But if I highlight quality, you can see there are some of them, they're pink. And that means that they read or written to. And the pink means that this is modification. So actually name is not modified by just looking at the colors. And because it fits on the screen, she's like, oh, name is not modified. Like, why is it var? Maybe we just do this. And less mutable data, the easier it is to work. And it passes the test, so I'll just commit this. And with quality, it's interesting. It's like pretty much every branch is changing it. And there is also cell-in, and cell-in is modified only in the middle once, which is like, it just gives us an idea. It actually modifies quality and cell-in, but mostly quality. On the other hand, like, is update quality a fair name? It modifies both fields, so maybe it should be called just update in this function. So maybe I'll just go with that then. And yeah, and this is all good. I guess the biggest breakthrough for refactoring this code is like noticing that name is, if I like search for name, it kind of highlights it everywhere. And you see that pretty much, well, everywhere except one place, it's like negated name comparison, which is really odd. So that's the thing to try. And there is this refactoring invert if condition. So I'll apply it here and then could apply it here and remove braces. And this is kind of cool structure, right? When say if name this, if name that. So that's very promising. It's a bit tricky here because we could invert condition, but that's not helpful. And we kind of we can split if into 2, but this is too nested. So what we need first is flip ends like this, then split if into 2, and then invert. It does early return, so sometimes you need tell ID, like help it to do more like the right thing. So this way, like inverts nicely, and then can remove this brace. Complains that if has an empty by this. I think if like do anything here, nothing, that will work, or maybe more Kotlin way to do unit. On the other hand, if each branch is kind of modifying quality, maybe something like that is better, so that it's like each branch is doing, like they're all similar. So yeah. At this point, it's also idiomatic to Kotlin maybe to convert this to when. And if we remove all braces, that actually looks really neat now. Now I can actually know what's going on there. And it's like, oh, okay, just comparing name and then updating quality, quite simple. So that's like the most, like, the biggest breakthrough, I think, of this refactoring. So we started at the bottom, so let's just go bottom up, right? And just invert this condition. It contains empty body, but similarly, we can do cell in 0. And then it's interesting that ID like highlights something else. So it's like, it's a bit like in a puzzle. If you improve one bit, like IntelliJ says, oh, actually, you can do that as well. And so he's like, oh, you can lift assignment out of if. And oh, let me join lines, maybe. Then if I do this, it does this transformation. So we had 2 cell-ins, and so like 2 points were mutated, we're mutating it. And if we do this, it's like 1, and this whole expression becomes like a pure functional, so it's like if-else, basically. So that's pretty cool. Maybe for symmetry, we can do when here. So this is a big branch of big chunk of code. Well, luckily, we can just alt enter and say invert. And it does it, and it even gets conditions correctly, right? So this or. That's cool. This name is equals. Here, we probably want the same trick. Flip, split if into 2, invert, join this line and say like quality minus equals 0. This should work. And it's like we inverted, but it's not as nice like as the one below. So the interesting thing is that there is also refactoring to split if into 2. So if we do this, like ID basically duplicates this thing twice, but like splits the or in the if. So now this condition, if we go, this is always true, always false, because we compared the name at the top, right? So this is false, then we can alt enter and delete. It's also interesting that these are the steps to not like assume and just delete it straight away. Do like in small steps and let ID delete things. And here this condition is always true, and we can simplify it like that. So that's much nicer. So now we're kind of back to that flat structure. We can replace it with when, remove braces, and kind of doesn't look as neat as the one below, but like, still more sensible than it was. Yeah, so that's better. And now we can again go with the like heuristic of like, oh, there is a bit of duplication. We just compare quality to something and then we increment it. So maybe we could go with this and say update quality, extract a function with the intention to make this parameterized and call this change. So now if we do it here, so let's run tests. So now we could like go around and replace updates here. So for example, this is if we split if into 2, these 2 bits are update quality 1, clearly. So yeah, this works. Also, if we think hard enough, and you have to believe me, I won't go into details, these are independent updates, so we can actually do this. And as you can see, this is again, it's the same code pattern. So we say update quality 1, that will work. And then you could go ahead and say update quality, let's say 0 here. And it still works. That's cool. But this goes into minus, and it's a different condition here because we're comparing to less than 50, whatever that means. So maybe at this point we should go and kind of read the requirements. And I'm not going to read the whole requirements, and maybe these requirements need to be refactored themselves because they say the quality of an item is never negative and it's never more than 50. And they have also special logic, but we'll see it later. So basically it's like that's the between 0 and 50, and that's what we see in conditions. So maybe we should embed this knowledge into this function, right? So I'll do it like this, maybe with assignment, and then I'll use heuristics function from Kotlin standard library. So it's between 0 and 50, and I'm doing it like an incremental step. So it's like first introduce heuristics, and then I'll try and remove the if here. And surprisingly, this fails. And if we look at the diff, so on the left-hand side is expected from the regression, and on the right-hand side is what we got. And it's like, oh, we're getting like, was 80, now it's 50. And 50 makes sense because that's what we put here. In practice, the problem is that there is a special requirement for sulfurous. Maybe you should leave here, actually, in this document. So I say it's just for clarification. It's 50, however, sulfurous is legendary, and it's 80, and never changes. So that's an interesting thing. So there are different ways to do it. We can like hard code the name of the item, or here maybe I'll do something simple like change equals 0. Do early return. So basically, if the change is 0, we don't touch the quality. So yeah, that passes the test. But now we should be able to do minuses as well, right? So it's like -1 should work. Update quality, this will be minus quality now. So we kind of, in some ways, you can see that we're going in circles. Like at some point, we've changed it from quality minus quality now like to 0, then we're going back. So there is no single successful path for this. And this should be 0, right? And this is -1. So now what we achieved with this is like we encapsulated modification of quality into this one function. And as we've seen, like this refactoring, which IntelliJ was suggesting to lift assignment out, we can have a similar thing by lifting function out of this expression. So there is this refactoring lift function call out of len. So if I do this, basically you can see like there were 4 update qualities in this branch, and now it's just 1. And here we have just an expression. And so that's pretty cool. I think I like that because, again, we're like pushing mutation out of the system. Like, you know, we used to mutate in every branch. Now we pushed it out a bit, so at least within when there is no mutation. And it would be nice to do something like that here. But if I alt enter, there is no lift. So like I'm searching for lift. It's not that. And the reason is that this branch is not an expression. We could refactor this. One thing is to realize these updates are independent, so we can reorder them like this. And that works. Then we can say if it's like value is less than 6, it's also less than 11. So we can do else and increment update quality. And similarly with this thing, we can just, we're always doing it. So if we put it into else, we increment numbers here. So that becomes an expression. So now we can lift function call out of here. That's going to work. Maybe it could be when, but I don't like this arrow. It's a bit like angle bracket, so it's like a bit confusing, I think. So maybe I'll leave it as a if. So now after we did this, we can lift like the function, the refactoring appears on alt-ent outside len. And so you can do this. It looks like there's lots of stuff happening, but I literally just like press an alt-ent to do this refactoring. And it's like easy to do. You don't need to think too hard. So that's all pretty cool. I think maybe at this point we should go back and like try and add conjugate mana finally. So what it was saying is like in the requirements, degrade in quality twice as fast as normal items. So I assume else is normal, so we can just do this and say twice, well, -1 multiplied by 2, and the same thing here. And yeah, it should fail the test. We can review the diff. So yeah, so on the left, so with day 0 we had initially 6, then on day 2 it goes to 4. We used to have 5, which wasn't correct. And then day 2 goes to 2, and then to 0. So this one, I could copy this whole regression, but we can maybe just reapply it in the requirements, in the regression as well. So don't need this to do anymore. We could just go first day 6, then it goes to 4. Oops. Then it goes to 2, and then becomes 0. I find it sometimes useful to even update these things manually because it also realized me it decreases by 2, but what if it was like 1 and then will it go into minus? It shouldn't, but yeah, just thinking this code coverage is maybe not the best. But in any case, this just shows that after the refactoring, it makes a lot of sense what we're doing now, and it's kind of clear that it's all fine. So yeah, so that's one thing. I think this code is fine as it is. Maybe like one thing to realize here is that like sell-in is actually sell-in days if you read the requirements. And if you think about it, we update and sell-in days in the middle of the function, but at the top we're using it for comparison, and at the bottom we're using it. So it's a bit weird. Like we like have different values, and actually this function, once you realize sell-in is about days, so it's a daily update of qualities of items. So actually, to me, it would make sense to move it to the top, for example. So like, you know, we started a new day and we update like the countdown, how many days are left for the item, and based on this, we update quality. So to do this, we'll have to change these numbers maybe to 5 and 10 because we decrement them now here. And then we'll see that the update quality is kind of, we're calling it twice. So maybe we can try and merge it into one update to reduce it. So one way would be to maybe extract this into functions, say expired. Also could convert this to property. And then to get rid of this, like I maybe take really slow steps. So one way to do it would be if expired, do this, else 0. So that's the safe transformation because we're just basically doing what we're doing, or else 0. But now we can unwrap this if condition from it. And as the next step, I can cut this, put 0 here, and I go to the top and just do plus. So that's also a state, like, we're just moving things around. And then I can, okay, if this worked, I can do like arithmetic and move this one into here. And then I can do the same thing with other branches. So if I move this here, it will be else like this. This is 0, 0, so that's 0. And this will be -2. So it was -2, so this should go into -4, -2. Right? And the last one was -2, -1, I think. And so doing this like step by step. So yeah, this all works now. All branches is 0. I can delete this whole thing. And I think the interesting thing about it is like, if you see the commit or pull request, you'll be like, oh, everything's changed. Like, how do you know it's even correct? But if you're doing like in tiny steps, or like pair program with someone, it's way more convincing that actually every step was very safe and we know we ran tests. And this is not captured in pull request. So maybe like we should record more details or something like that. Or like even if you do it through refactoring, maybe it should be recorded and be like metadata, but actually nobody typed code during this commit. It was just safe refactorings. So yeah, my version controls should get richer, like Git is a bit boring. So yeah, that's like one thing. Maybe the next steps where I would go is like maybe make it less mutable. So these vars are not ideal. And there are like a couple of ways of doing it. So one is like, yeah, I'll just make it a val, and then maybe this, and then you know, it's like the code goes red, right? So it's not even compiling. So it's like maybe we want to, we maybe want to create a copy, but then we need to update. So it's quite hard actually to do it. So maybe we should. So it's better to like do smaller steps, I guess. One thing that was interesting before even doing that selling is updated right here in the function, but quality is updated in a different function, but they're like the same fields in the same object. So maybe I'll try and, oops, if I invert this condition, I can inline this function back into here. So at least quality is now updated here and selling here. Maybe these could be actual functions like this. Update quality. And this could be update selling. So yeah, this will work, right? And to make it more functional, like sometimes it might be interesting to start with like inside out and but keep code compiling, because if something fails, you will actually know what broke it. So like one step would be like, let's make these functions return item, assuming that in the future it won't be mutable. Then if they both return item, we can do this, return update. And this update shouldn't be for each, it should be a map. And it should reassign to items like this. We're still mutating objects, right? And the next thing would be maybe make it a data class because we want to copy things. And it's like everything still works. And then I guess we want to have a copy, so maybe something like this. We do copy and we create new 7 days. So this fails the test, and we're like, oh, that's a strange thing. The reason is that here in the regression, we have items which are passed to Gilded Rose, but we should probably do is like go through items on the object itself because that's the object we're replacing now. So that will make the test pass. So this could be a bit more functional like that, and similar thing with quality. You could just return a copy here. Yeah, and then finally we can go and make this vals. And the interesting thing that's like at every step you don't break code for too long, but yeah. But sometimes it might be okay to break it just to discover the best approach and then go for something like that. So this is like the whole demo. I just doing a mini retro. So what we did had a regression test, which is convenient to have. Then we extracted item update, condensed code, looked at item properties usage, the biggest breakthrough of flattening if-elses with refactorings, moved mutation out of branches, merged update quality calls with expiration, and moved mutation out of items. So that's what we did. Like, what did we learn? I guess what I learned by doing this exercise a few times, that you can discover design through refactoring. So you don't need to have a great plan. You just like try lots of different things and then something emerges. Then ideal refactorings guide us in interesting directions. That's pretty cool. Yeah, there are some refactorings which are hidden, like intentions. I think ID experience, maybe it could have been improved in some way, because like you do Altenta, and some of those things are genuine refactorings, some are not refactorings. Like there is no way to know really which one are safe to use. Right? Yeah, I guess keeping code compiling and test green at all times, if you actually try exercise, this is a very useful approach compared to like something broken and you're stuck for a long time. And I guess tied in until the code is ready to change, like to demonstrate, like adding conjured item, conjured mono, was much easier when like the structure was very clear. And in terms of mechanics, what I'm using, IJKL shortcuts. That's if I navigate it quite quickly, it's because I'm using this shortcut. So it's a plugin for IntelliJ. It's like replaces arrows. So it's IJKL is like gaming layout. But on the right-hand side, it's like WSD, but on the right. And this is basically, these are the shortcuts. Also use Alt-H to jump to the source. It's like a 4 on default layout, and B to go back, so that's like easy to navigate. Yeah, I guess Alt-Ent everywhere. This is how you can find things. This is very useful. I'm using quick fix for F1 and F2 to navigate to warnings or navigate around. And quick fix, that's the plugin I did. It's quite simple. And I think this is like unfair because like I am showing so many things, but actually I don't show like the shortcut pop-ups because if people use it, just I won't remember much. I'm only learning one thing at a time. Like I'm showing it too much to you to remember. Just learn one thing, just keep doing it for a while and have fun while learning. So yeah, just like I learn one thing at a time. So don't feel bad if it's too much and overwhelming. There is like the question I should have started with, maybe like why refactor? For example, if chatbots will write code for us. I mean, I'm not going to show it, but I guess chatbots are not that good yet. But yeah, maybe we should have chatbots to refactor our code. That would be interesting. Yeah. Why wouldn't we get like everything in the right place, all the code? And I think it's like obviously not true. But even if you could get something right in the first place, the world around you will change. And, a perfect Kotlin code you wrote today will be obsolete in 10 years. Or something else will change, like the world you model will change. So, yeah, I think there is an interesting thing like why refactor, if it will be rewritten, lots of software is rewritten. And I think in practice is, well, like maybe it's a vicious circle or some like feedback loop that if we had better refactoring tools and approaches, then maybe we wouldn't have to rewrite software every few years. And there is also more like social thing of why refactor if someone else writes bad code faster, like chatbots or your colleagues. So that's also interesting. That's more like organizational thing. And I was like showing it like this was a very geeky like talk about like code, but actually like code doesn't exist and so on. It's all integrated with you, how you relate to your colleagues. And this is quite an angry question. And it's like, and your relation with colleagues and a whole organization. So like code is not isolated thing. It's like why someone's writing bad code. Maybe they're under pressure. Maybe like there are other forces. So maybe you should refactor your organization. It's like, you can scale up in different ways. Basically, everything I mentioned is here. That's a good book. But it's a bit old. There was JavaScript edition, but I wish someone did it in Kotlin, or maybe Kotlin with chatbots. So if someone writes a book, please consider refactoring in Kotlin. There is also Yeah, there is also a book by Canberg, just came out in October, called Tidy First, but it is about refactoring, really. Looks good to me. And if you're interested, there is Duncan McGregor on YouTube, and he says, hello, it's Duncan. And he did this Kata, which is basically follows from where I finished now. So if you want to watch more, you can see Duncan. And I have some stuff on YouTube. So the important thing, just go home and try it yourself in a different language. You do it in reverse, like you start from the end and then you like trying to mess it up to the same state. And it's just there on GitHub. Thank you.